Okay, so now we're looking at differentiating exponential functions, and this won't be a very long lesson, and the main reason is this. If you have a function y equals e to the x, when you differentiate that, so dy by dx, you actually get e to the x. So whatever your exponential function is, you differentiate it and you get e to the x. Of course, it's not quite as simple as that in every example, but it doesn't get that much harder. So let's say we've got y equals e to the 3x squared. When you differentiate this, it goes to, obviously you've got the 3 to the, so e to the 3x squared. So the main thing to remember is that the power stays the same. However, whatever is up here, we differentiate, then we stick it in front. So 3x squared differentiates to 6x. So it differentiates to 6x e to the 3x squared. So again, very, very simple. So if you have a look at these examples, so we've got 5e to the x. So if we've got y equals 5e to the x, differentiate that, dy by dx, 5e to the x. If we differentiate the x, that becomes 1. So if we then bring the 1 down, that just remains as 5e to the x. So that's the answer for that one. Next one. If we have y equals e to the 2x plus 3, differentiate this one, so dy by dx. Of course, it stays as e to the 2x plus 3. If you differentiate this, that becomes just 2. So you bring the 2 down to the front. So it's 2e to the 2x plus 3. Now, of course, it's never quite as easy. And so what we tend to do is we tend to link the skills together. So if we have a look at question C here, we've got x, and then we've got e to the x squared. So that type of question, of course, is product rule. So we've got y, that pause, by the way, was me allowing you to all shout at the screen. X e to the x squared. So what we do is we split this up. So we've got two functions multiplying together to make a composite function. So the first one here we're going to call u, and the second function we're going to call v. So if u equals x, du by dx equals 1. V equals e to the x squared. So if we differentiate that, dv by dx, that equals, so if we differentiate the x squared up here, that goes down to 2x. So we've got 2x e to the x squared, because remember the power always stays the same. Once we've done that, we put it into u dv plus v du. So u dv is going to be x multiplied by 2x e to the x squared, which would give us 2x squared e to the x squared, plus v du, which is e to the x squared times by 1. And just like with the quotient rule or the product rule, getting to this point is going to be worth the most amount of marks. Then what you can do then is tidy it up a little bit. So this is what dy by dx equals. And then you can tidy that up by factorising it. So if you factorise out e to the x squared, that goes to then 2x squared plus 1. Now we don't just tidy it up for the sake of doing it. A lot of the time you'll want to find out where a turning point is. Now if you go back to C1 or C2, a turning point is where the gradient is 0. So for this equation here, it's tricky to find out where the turning point is 0. However, if you set the bottom one equal to 0, then we either set e to the x squared equal to 0, which turns out you can't do, more about that another time, or we set this bracket equal to 0, which turns out we can't do either. So in which case there won't be a turning point for this function, but at least we know. Okay, the final example that we're going to have a look at is we're going to have a look at question D here. So we've got e to the 2x plus 3 over e to the power of x. So the first thing to do is notice there's a quotient because we've got a function on top and a function underneath. So the function on top we're going to call u. So it's going to be e to the 2x plus 3. And we've got v, which in this case is just x. So du equals e to the 2x plus 3. Of course, we've got to differentiate that, then bring it down. So if we differentiate 2x plus 3, we just get 2. If we differentiate v, we get 1. So again, the quotient rule is v du minus u dv all over v squared. So using this, v du is going to give us, so we multiply the x by the 2e to the 2x plus 3. So that's going to give us 2x e to the 2x plus 3 minus u dv, which is just e to the 2x plus 3 all over v squared, which in this case is x squared. And so now we've got to tidy that up. So we factorise out the e to the 2x plus 3. So our final answer, dy by dx. So once we differentiated it, we get e to the 2x plus 3 bracket 2x minus 1 all over x squared. Then what we do is we double check to see whether or not we can simplify the denominator on the top. So we've got x squared down the bottom, but we haven't got any x on the top. So that's how we leave it. Okay, thank you, ladies and gentlemen. What I'd now like you to do, please, is go on to whichever page it is and have a go at exercise 8D. You've got 7 questions there. Even though it's quite an easy topic, there's a lot more questions because you're now using the quotient rule, the product rule, and the chain rule to do all the differentiation. So off you go and have a go at that.